Alright, let's work on finding the derivatives of these different functions. We are still going to use the same techniques that we used in Unit 1. So determine the derivative of s of t equals square root of t. Now we can use the derivative notation s prime of t. We're starting with our first principles. So s of t plus h minus s of t over h. And if I fill in instead of t, just a limit h approaches 0, t plus h minus square root of t over h. We are going to multiply the conjugate. So whenever you work with square roots, the tip is multiply the conjugate. T plus h plus square root t over t plus h plus square root t. So first square root squared gives you t plus h minus second square root squared is just minus t h. I'm not going to expand my brackets out. Okay, simplifying a little bit, t and negative t will cancel each other. I'm left with just a t on the top, so let me cancel t and the t on the bottom. It leaves you with 1, okay, not 0. H divided by h is 1. The bottom still has square root t plus h plus square root t. If I let t equal 0 now, h equals 0, 1 over t plus 0 plus square root t, 1 over square root t plus square root t, so this is 1 over 2 square root t. So there's our general formula. So derivative of my function s. There you go. So we're just doing the same process with a general letter t instead of like a specific point, like a specific number. And now you can take any point and plug it in to find the derivative at that point without having to calculate it over and over again. Question 3. If f of x is equal to 1 over x, determine the equation of the tangent line to the curve. And then it says find the slope of the tangent at these two certain points. So start with A. Starting with my f prime x equals my first principle, so let's write limit h approaches 0 for my function x plus h and the function of x over h. and plugging in the actual function, 1 over x plus h minus 1 over x over h. Limit h approaches 0. I'm going to just kind of take them separately. The top, we want to do the common denominator. So multiply x into my first fraction and x plus h into my second fraction. I will not skip a step. I'm just going to set 1 over h aside like this. Make it into one fraction, so x minus x. Remember to distribute minus h, okay, because this minus applies to both x and the h. Watch your signs. The bottom is just x times x plus h. Well, 1 over h. Okay, again, simplifying a little bit, x and minus x, they can cancel. And I have just a negative h and an h. I can cancel those out, so I'm left with just 1. Again, it's a negative 1, I guess, not a 0. So limit h goes to 0, negative 1, x plus h. Let's plug in the numbers. So let h equal 0. You have negative 1 over x times x plus 0, which just leaves you with negative 1 over x squared. So that's your general formula. So derivative for my function x over 1 is equal to negative 1 over x squared. Okay, question B. Now I can take it and sub in these numbers, so my derivative at negative 3 would be negative 1 negative 3 squared, which is negative 1 over 9. My derivative at 2 is negative 1 over 2 squared is negative 1 over 4.